Hello students, today we are going to see about chapter 3 understanding quadrilaterals. In this video we are going to discuss about the introduction as well as the exercise 3.1. Okay, so before going to the exercise we need to know about a few terms. So curve is nothing but a line. Okay, so any line we can name it as a curve and it can be straight or it can be a bended curve. So for example, if you are drawing something, okay, so if we are drawing something like this, okay, so it is a bended curve, it is a curve, okay, and this is also a curve. So when we draw a straight line, it is also a curve, okay. So when we are drawing something without lifting the pen from the paper, we can name it as a curve. And what do you mean by simple curve? So simple curve is one which does not intersect itself. Okay. So for example, if we draw like this, okay, so it doesn't intersect anything, right? And if we draw like this, okay, so we have drawn a shape by using a line segment, okay. So there is no intersection, there is no cross in the curve, okay. For example, if we draw like this, okay, so here we have intersection point, okay, so this is not a simple curve, okay. So if we draw a star, right, here we have multiple intersection, different places I have cross or we can say intersection point, okay. So these two are example for the simple curve. So whenever there is no intersection, we can say that it is simple curve, and these two are non-simple curve. Why? Because we have intersections. Okay, so when we have intersection, it is called non-simple curve. When we don't have any intersection, it is said to be a simple curve. Okay, and then next is open curve. Okay, a curve which has open ends. For example, like this, if I am drawing, okay, this end and this end is open, so it is an open curve, and I can draw like this also, okay. So these are all the example, because this end is not closed, that is this starting end and ending end is not attached, okay. So it is a example for the open curve. For example, if you draw like this, again this is a open curve, okay, so the ends are not closed, okay, that is such type of curve is nothing but open curve. And then closed curve. What is closed curve? Closed curve is a curve which has no open ends. It is closed. Actually, your starting point and ending point are the same point. Okay. So whatever the general shapes we have studied in the mathematics, like square, right, and then rectangle. Okay. So where we are starting, there we will end. Your circle. Okay. So your starting point and ending point are same, and it doesn't have any open end, okay. So such type of curve is nothing but closed curve. And then polygon. So what do you mean by polygon? Polygon is a simple closed curve, okay, and that too it should be made up of only line segments, okay. So for example, as we have already discussed, right, so we can take example of square, okay. So we can have a square. So I'll draw neatly. So I can have a square, okay. I can have a rectangle where I use only the line segments, okay. So I can say a triangle, okay, multiple types of triangle, because all these are closed and also it is made up of only line segments, okay. So such type of thing are said to be a polygon, okay. So a simple closed curve with only line segments, okay, which is not a line, which does not have, not only have line segment but also have curve, it is said to be a non-polygon. For example, if you have circle, right, it is also simple closed curve but it is not polygon, okay. So if I have curve like a structure like this, okay, curve like structure, it is closed but it is not a polygon because I have curve, okay. So anything, You can draw differently like this. Okay, it is a simple closed curve, but it is not a polygon. Okay, so whenever you are drawing the shape with only line segment, I can say that it is polygon. That too, it should be a simple closed curve. Okay, so convex polygon is nothing but all interior angles are less than 180 degree. Okay, so for example, we can take all these shapes, all these three shapes, or this one also we can include. All these things are convex polygon. Why? Because all the interior angles are less than 180 degree. For example, when we take this structure, right, so this is the angle, right? All the angles are 90 degree, which is less than 180 degree. Similarly, in all the shapes, okay, so the interior angle means angle inside the shape. Okay, so interior angles are always individually, it is less than 180 degree. Okay, and concave polygon is at least one of its interior angles measuring more than 180 degree. Okay, for example, if I have structure like this, okay, here it is less than 180 degree, here it is less than 180 degree, here it is less than 180 degree, here also it is less than 180 degree. But what about here? This angle, okay, so any one of the interior angle will be more than 180 degree. Okay, so if it is so, we can say that type of shape, that type of polygon as a concave polygon. In simple, I can say that whenever I have a line segment joining any 2 point will be the interior of the polygon. For example, I am having a line segment here, which is there interior in the shape itself. Okay, it is going inside. Okay, so if any line segment, it is going inside the shape. Okay, inside, when it is going interior of the polygon, then we can say that it is concave polygon. Okay, so when you don't have any interior thing, right, interior line segment, I don't have any interior line segment here. Okay, so it is convex. Okay, but when we have any interior polygon, any interior line segment like this, it is interior, right, it is interior, it is going inside. Okay, or we can say that we have some dent, right? So if it is so, we can say that it is a concave, it is a concave polygon. Okay, and then regular polygon is a polygon which is having all the angles are equal as well as all the sides are equal. Only such case is said to be a regular polygon. So simple example is your square, because all sides are equal and angles all angles are equal. So whenever all angles are equal, we can say that it is equiangular. When all sides are equal, then we can say that it is equilateral. Okay, so when all the sides are equal as well as all the angles are equal, we can say that it is a regular polygon. So I'll give one more example. For example, you have equilateral triangle. So triangle, you have multiple triangle, right? Like this right angle triangle you have, but here, right, so here angles and all, it is different. Okay, you cannot say that it is regular polygon, but here equilateral triangle, all the angles will be equal as well as all the sides will be equal. So these two things will comes under regular polygon. Okay, and it is irregular polygon because I don't have your angles to be equal. Okay, also my sides will not be equal. Okay, sometimes in some structures, even though your sides and all are equal, but angles may not be equal. Okay, so such shapes are said to be a irregular. Both your sides as well as angles should be equal. So with this knowledge, let us go for the exercise 3.1. So given here are some figures, okay, classify each of them on the basis of the following, okay. So what is simple curve? What we have discussed? Simple curve, okay, so it is nothing but any line. So wherever you are starting, right, and if you are drawing something, okay, without taking your tip of the pen from the paper, I can say that it is a simple curve, correct. So it may have a curve, it may have a line segment also, okay, and it may be a open curve, it may be a closed curve. That is said to be a simple curve and without any intersection, okay. That is also a main thing, okay. There should not be any cross, any intersection, okay. That is said to be a simple curve. So with this knowledge I can say that it is simple curve because there is no intersection, okay. So simple curve are this one, okay, that is your first diagram. And again coming to the second diagram, this is also simple curve, right. So when I start like this, I can draw like this, okay. So this is also simple curve. What about third diagram? So I am drawing like this and I am taking the tip of the pen against the second curve, okay. Since I am taking the tip of the curve, this will not come under the simple curve. And fourth diagram, I have intersection. So if I have intersection point, this is not a simple curve. Fifth one, so I am drawing like this, okay. So it is a simple curve. Without taking, I can draw the diagram and there is no intersection. And then sixth one, again it is a simple curve. Without taking the pen, I can draw this diagram. Seventh one, again it is a simple curve, right. And then what about eighth one? Eighth one, I am drawing like this and leaving this, okay, and again drawing like this and leaving this and again drawing a third structure. So I will be taking the tip of the pen outside to draw the eighth diagram. So that is also not a simple curve, okay. So these three will not come, only 1 2 5 1 2 sorry 1 2 5 6 7 will come, right. This is not 3, this is 5, okay, because 3 will not come, 3 will not come, 4 will not come, 8 will not come. 1 2 5 6 7 are simple curves, okay. And then coming to the simple closed curve. So what is closed curve? All are closed curve. Oh, there is no open curve at all, right. There is no open curve at all are closed curves. So everything whatever we have discussed here, it is also applicable here, okay. So 1 2 5 6 7 everything are simple closed curve, okay. What about the polygon? So polygon is one which is having only the line segment. First of all, it should be a simple closed curve, and also it should have what? Only the line segments, okay. So in this 5 diagrams, okay, in this 5 diagrams which is having only the line segments, this one and this one, okay. So polygon is nothing but 1 and 2, okay, because here I have curve, here I have curve, here also I have curve, okay. So these things will not come, only the line segments is nothing but 1 and 2 structure, okay. Convex polygon. So out of two structures, which is convex, convex is only this one because I don't have any interior line segment, right. So this is convex, and also all the angles it is of less than 180 degree, okay. So second shape is convex. What is concave polygon? Again from these two I have to find out which is concave. I have interior line segment, okay, as well as this angle is more than 180 degree. So first shape is nothing but a concave polygon, okay. And then next slide. So here second question is, what is a regular polygon? Okay, what is a regular polygon? The polygon with equal sides and equal angles, okay. It is nothing but a polygon, regular polygon. So equal sides, equal angles, it should be a regular polygon. State the name of the regular polygon. Name of the regular polygon of three sides, okay. So already we have discussed in the example, right. So three sides means we can say that equilateral triangle. So equilateral triangle is the answer for 3 sides. We have to state the name of the regular polygon. So here all the 3 sides are equal, all the 3 angles are equal. Okay, so example is equilateral triangle. So similarly state the name of a regular polygon with 4 sides. Simple. With 4 sides means it is a square. Okay, so all the 4 sides are equal, all the 4 angles are equal. Okay, so example for this is regular polygon with 4 sides is square and 6 sides. Okay, so 6 sides means we can think about the hexagon. Yes, right. So okay, this is a regular hexagon. Actually if we draw irregular hexagon also, right, it will be of 6 sides, but sides will not be same. Okay, so if we draw the regular hexagon with all the sides, with all the 6 sides equal and all the angles will be of equal. Okay, so regular hexagon is the example for the 6 sides. Okay, so thank you, thanks for watching.